the first two terms of an infinite GP are together equal to 5, and every term is 3 times the sum of all the terms that follow it. Find the series. Okay, so we are given a series. S is equal to, the first term is, let us say it is A, the second term is A times R, the third term is A times R square, A times R cube, and so on. And we are given that this is an infinite series, so we know that absolute value of R is less than 1. Now it is given that the first two terms is equal to 5. So we are given that A plus AR is equal to 5, or A times 1 plus R is equal to 5. Now what is the other information that we are given? We are given that every term is 3 times the sum of all the terms that follow it. Okay? So let us divide our point somewhere here. Okay? We have A, and all the terms that follow it are these terms. Okay? Now it is given that A is actually equal to 3 times the sum of all these terms. Now these terms also, that is AR plus AR square plus AR cube, is also an infinite geometric progression. The sum of this infinite geometric progression is the first term, which is AR, divided by 1 minus common ratio. Common ratio is R. So this is what we get. Now A is not equal to 0, so we can cancel A from both the sides, and we can solve this equation to find the R, right. So it means that 1 minus R is actually equal to 3 times R, or R is equal to 1 by 4. Now just put R is equal to 1 by 4 here. We get A, 1 plus 1 by 4 is 5 by 4 is equal to 5, and therefore A is equal to 4. So what is our series? Our series is actually A, which is 4, and then the common ratio is 1 by 4. So you have 4 plus 1 plus 1 by 4 plus 1 by 16, and so on. Okay, in problem number 4 we have to sum this series. Let's find the sum of this series: x plus a, x square plus 2a, x cube plus 3a up to n terms. So let us write sum is equal to x plus a, then x square plus 2a what is the nth term going to be? We can see that the first term is x, second term is x square, third term is x cube. So nth term is going to be x to the power n, plus first term is a, 2a, 3a. So nth term is going to be na. So we have to find the sum of this series. Now it is easy to see that this sum is actually made up of one arithmetic progression, which is a plus 2a plus 3a till na, and it is also made up of the geometric progression x plus x square plus x cube plus x to the power n. All I have done is I have just rearranged this addition so that we have one arithmetic progression and one geometric progression. So this is a, if you take one a common out, you get 1 plus 2 plus 3, and all you have is sum of n natural numbers. and if you take x common out here, you have 1 plus x square plus x to the power n minus 1, right. Now this we have seen in the past also. You can apply the arithmetic progression sum formula, but this is a special case where you have common difference of 1. It is actually the sum of n natural numbers, which is simply a times n plus 1 divided by 2 plus x, and now this is the sum of the n terms of geometric progression. So where the first term is 1, so this is 1 minus, just apply that formula, 1 minus x to the power n divided by 1 minus x, and this is how we can solve problem number 12. Okay, problem number 13 is a similar problem. We have to sum the following series. It is x times x plus y plus x square times x square plus y square plus x cube times x cube plus y cube, and so on. So what is the nth term going to be? We see that the first term is x square, x cube. So we know that the nth term is going to be x to the power n times, what is the first term here? X plus y. Second term is x square plus y square. Third term is x cube plus y cube. So the nth term is going to be x to the power n plus y to the power n. So we know what our nth term is going to be. So we have to just find the sum of this n terms. We can write this sequence as series is, just expand it, so you get x square plus xy. This is the first term. Second term is x to the power 4 plus x square y square. Third term is x to the power 6 plus x cube y cube, and nth term is going to be x to the power 2n plus x to the power n y to the power n. Now you can see that again, just like in problem number 12, this series is made up of two progressions. We can put x square, x to the power 4, x to the power 6 in one group, xy, x square, y square, x cube, y cube in another group, right? So what we have is, we can write s is equal to x square plus x to the power 4 plus x to the power 6 all the way up to x to the power 2n. This is one geometric progression that we can see, and the other geometric progression is going to be xy plus x square y square plus x cube y cube all the way up to x to the power n y to the power n, right? Now we can simply apply the formula of summation of n terms of this geometric progression. So s is going to be, what is the first geometric progression sum is going to be? It is the first term, which is x square, 1 minus, what is the common ratio? Common ratio you can see is x square. So x square, how many terms are there? There are n number of terms here, okay, from x square to x to the power 2n. So this becomes 1 minus x to the power 2n divided by 1 minus x square. So this is the sum of the first geometric progression plus, what is the first term here? it is xy, 1 minus, what is the common issue? Common issue is also xy. So it is xy, and how many terms? It is n number of terms. So it is to the power n divided by 1 minus xy, and we are done.